Hello everyone, welcome to your physics class of class 7th. I hope you all will be fine. Students, this is our part 2 explanation of lesson number 1. In part 1, we discussed about volume. Now today in this video, we will discuss about area and density. Okay, so let's begin our class. Area. What is area? As we all know that area is a surface occupied by an object. Okay, the surface occupied by an object is known as its area. Okay, SI unit of area is meter square. Okay, written as meter square. So this is SI unit of area. Now, suppose if we want to measure the area of a playground or a football field or a village or a town, so meter square is a smaller unit. So we need to, if we need to find out the area of a playground, we need bigger units. So bigger units of area are kilometer square, okay, and hectare, square, decameter. Okay, square decameter, hectare and square kilometer. 1 acre is equals to 100 meters square. 1 hectare is equals to 10 raised to the power 4 meters square, or we can say 100 acres, and 1 square kilometer is equals to, or we can say 1 kilometer square is equals to 10 raised to the power 6 meters square. These are bigger units of area and the relationship between bigger units and SI unit of area. Okay, now if we want to find out the area of smaller objects like pencil, rubber, etc., we need smaller units of area. So smaller units of area are centimeter square and millimeter square, and relationship between centimeter square and meter square is 1 centimeter square is equals to 10 raised to the power minus 4 meter square. As you all know that 1 centimeter is equals to 1 upon 100 meter. Therefore, 1 centimeter square is equals to 10 raised to the power minus 4 meter square. Same way, 1 millimeter square is equals to 10 raised to the power minus 6 meter square. These are the relationship between different units of area and the SI unit of area. You have to learn all these relationships. Now, next one is measurement of area of regular objects. To find the area of regular objects, okay, we can find the area of regular objects by using these relations. By finding out the dimension of a particular object, we can use these relations to find out the area of a regular object. For example, to find the area of a square, first we need to find out the dimension, that is this side of a square, and then by finding out the side of the square, we can easily find the area of a square by using the formula side square. Same way, if you want to find the length of a rectangle, then we can use the formula area is equals to area of rectangle is equals to length into breadth. Area of circle is equals to pi r square. Surface area of cylinder is equals to 2 pi r into that is radius into length, and surface area of sphere is equals to 4 pi r square, where pi is the value of pi is 3.14 or 22 upon 7. By using these formulas, we can find out the area of regular objects. But now, if we want to find out the area of an irregular object, means if we know the formulas for regular objects, but if we want to find out the area of an irregular object, how we can find it? So by using a graph paper, we can find the area of an irregular object. Now, what you have to do in this method, we need to take a graph paper. Okay, as you can see here, this is a graph paper. Now we have to plot the outline of the irregular object whose area we need to find out, and then place it first we have to take the graph paper and then place the irregular object whose area is to find out, and then by drawing the outline of this irregular object, and after removing that object, then we calculate the number of complete squares that are obtained in this area of this irregular lamina, and also by counting the number of incomplete squares that are more than half. Okay, so by adding the number of complete squares and the squares that are incomplete but that are more than half, and then adding both these, we can calculate the area of this irregular object. As you can see here in this figure, the number of complete squares in this closed lamina is 4 are 4. Okay, number of complete squares are 4, and also the number of incomplete squares are that are more than half are 4. Then by adding these two, we get the area of this irregular object, that is 8 centimeter square. Understood how to find out the area of an irregular object? Okay, now you may be asked to find the volume of an irregular sheet of finite thickness. For this, find the area of by using the graph paper and thickness by using a meter ruler, and then we can find the relationship this volume by using the relation volume is equals to area into thickness. Okay, now next one is density. This is all about area. Now density, what is density? Density is mass per unit volume. Okay, mass per unit volume is known of a substance is known as its density. Now before studying about density, let us see these uh, experimental observations that each body has a certain mass and a definite volume, and it is observed that equal masses of different substances have different volumes. Means equal masses of different substances have uh, different volumes. For example, 1 kg of iron is this much and 1 kg of cotton can be this much. Okay, so both this iron is mass of iron, and also mass of this cotton is 1 kg. Okay, mass is same, but the volume of both these substances are different. Okay, so therefore equal masses of different substances have different volumes. Second is equal volumes of different substances have different masses. Equal volumes, suppose this is a piece of uh, wood, okay, and this is a piece of iron. Now these both the pieces have equal volumes. Okay, suppose these both have equal volumes, but the masses of both these substances are different, because you know that iron is heavier than wood. The same piece of the size, if we have taken the two pieces of one piece of wood and one piece of iron, but you know that the same volume of both these substances have different masses. Means equal volumes of both these substances will have different masses. As you know that iron is heavier than wood, therefore this the density of iron is more than the density of wood. Understood? Therefore it is said that equal volumes of different substances have different masses. For example, cubes of iron and wood will weigh differently. Means the cube of a wood, okay, and iron both weigh differently. This will be heavier compared to this cube. Understood? Now we can understood this equal masses of different substances have different volume by this activity. So in this activity, what we have to do, we have to take a beam balance, and then we have to place this weight of 1 kg, that is a piece of iron, on one pan of the beam balance, and on the other pan 1 kg of sugar. Now when this sugar is also of 1 kg weight, this beam balance will be balanced. But as you can see clearly here in this picture, that the volume, that the piece of this iron is occupies less space, that is the volume of iron is less as compared to 1 kg of sugar. Thus we can say that equal masses of iron and sugar have different volumes. Okay, now to understood this volumes of different substances have different masses, let us see this activity. Take 4 cubes of same size that but made up of different substances. For example, the substances here taken are iron, aluminium, glass and wood. Now label all these cubes as A, B, C and D respectively. Now, since all the cubes are of same size and have equal volumes, means all these four cubes that is made up of iron, aluminium, glass and wood, they are of same size and therefore they have equal volumes. Now take a beam balance and place these cubes one by one on each of these pan. Okay, first they have taken one side they have taken iron and on the other pan aluminium. Now you will observe that this you will notice that the mass of iron cube A is more than the iron cube B is made up of aluminium. Now compare the masses of aluminium cube B and glass cube C. As you can see here they have taken aluminium and in this pen they have taken the cube of glass. You will notice that the mass of aluminium cube B is more than that of the glass cube C. Now by comparing glass and wooden cube that are also of same size and same volume, uh, you will notice here that the mass of glass cube C is more than the wooden cube D. Thus, these all cubes have equal volumes, but they have different masses. Okay, thus equal volumes of different substances, iron, aluminium, glass, and wood have different masses. So from here, it is concluded that equal masses of different substances have different volumes and equal volumes of different substances have different masses. Understood all of you? Now, from the above activities, it is noted that 1 kg of sugar occupies more volume than 1 kg of iron. So we can say that iron is denser than sugar. In other words, the particles of iron are so closely packed. As you all know, the particles of iron are so closely packed while those in case of sugar are loosely packed and therefore iron is denser than sugar. Now, the mass of iron cube is more than the mass of identical aluminium cube. So, we say that iron is denser than aluminium. And aluminium, on comparing aluminium cube and glass cube, aluminium is denser than glass and glass is denser than wood and also milk is denser than water. Thus, to distinguish between different substances, we use the term density. Okay, that is density. Here it is said that iron is denser than aluminium, that is the density of iron is more than that of aluminium. Here aluminium is denser than glass, therefore the density of aluminium is more than that of glass. Here glass is denser than wood, that is the density of glass is more than that of wood. Density of milk is more than water. Okay. Now what is density? The density of a substance is defined as the mass of a unit volume of that substance, that is mass per unit volume of a substance is known as density. Let V be if V is the volume of a substance and M the mass of the substance and D the density. Therefore, density is equals to M upon V. For example, the mass of an iron cube of volume 10 centimeter cube is found to be 78 gram. That is, by using this formula, then mass upon volume, mass is 78 gram and the volume is 10 centimeter cube. Therefore, the density of iron is 7.8 gram per centimeter cube. Same way, the mass of water, 1 centimeter cube of water is 1 gram. Hence, the density of water is 1 upon 1, that is 1 gram per centimeter cube. Therefore, this is the unit of density, gram per centimeter cube. Density, unit of density is equals to unit of mass upon unit of volume. Now, if we are taking the unit of mass as kilogram and unit of volume as meter cube. Therefore, the unit of density will be gram per meter cube. Okay, so SI unit of density is kilogram per meter cube, or we can write it as kilogram m meter minus 3, kilogram meter minus 3. Now the CGS unit of mass is gram and volume is centimeter cube. Therefore, the CGS unit of density is gram per centimeter cube. Now, the relationship between SI unit and the CGS unit is 1 gram per centimeter cube is equals to 1000 kilogram per meter cube. As you all know that 1 centimeter cube is equals to 10 raised to the power 6 centimeter cube. Okay, and then keeping this this value in the formula, in this 1 gram per centimeter cube is equals to 1 gram is equals to 1 upon 1000 kilogram, and 1 centimeter cube is equals to this meter cube. Then keeping these values here, we get the relationship between 1 gram per centimeter cube and kilogram per meter cube. Understood, all of you? Now, the density of almost all solids, liquids and gases decreases with the increase in temperature because they all expand on heating with the exception of water. Because water contracts on heating from 0 to 4 degrees Celsius and expands on heating above 4 degrees Celsius. Therefore, the density of almost all the solid, liquid and gases decreases with increase in temperature. Now, the density of water is maximum at 4 degrees Celsius and it decreases when it is cooled from 4 to 0 degrees Celsius or heated above 4 degrees Celsius. Now, determination of density of regular objects. To find the density of regular objects, we can use the formula mass upon volume. Then by finding the mass of a substance using a beam balance, and to find the volume of a regular solid, we can use the formulas of that particular solid, and by using the relationship between density is equals to mass upon volume and keeping the value of mass here and keeping the value of mass here and value of volume here, we can calculate the density of a regular solid. But if we need to find out the density of an irregular solid, first we have to calculate the mass of an irregular solid with the help of a beam balance and let it be m gram. But for finding out the volume of an irregular solid, as I already told you in my first part of the video, to how to calculate the volume of an irregular solid by using the method of displacement method, the displacement of water method, we can find out the volume of that irregular solid. Okay, to know this method, you can watch, if you have not seen that video of part 1 of the explanation part of this lesson, you can see that video. Then by using that method, we can find out the volume of an irregular solid. And then again, by using the formula density is equals to mass upon volume, we can find out the density of an irregular solid. Understood, all of you? Now, to determine the density of a liquid. Now, to determine the density of a liquid, follow this procedure. For what you have to do, you have to take a beaker and measure the mass of the beaker, empty beaker, by using a beam balance, and let's say it be M1. Now, take a measuring cylinder and pour milk into that cylinder. Okay, you have to take a measuring cylinder and then pour milk. Suppose we need to find out the density of milk. So pour this milk, whose density is to be find out. Pour that milk in a measuring cylinder up to 50 ml, or we can say 50 centimeter cube, as we know that 1 milliliter is equals to 1 centimeter cube. Now transfer the milk into the empty beaker whose balance we have whose mass we have already balanced with the help of a beam balance. Now pour this milk into that empty beaker. Now the difference between the masses here, from here we have find out the volume of the milk. Now for mass of milk, subtract the mass of the beaker with milk minus the mass of empty beaker. Say the mass is 51.5 gram. Let the mass is 51.5 gram. Therefore, using this relationship again, density is equals to mass upon volume. Mass is 51.5, means the by subtracting the mass of empty beaker from the mass that we have calculated after we have poured milk into this beaker. So the difference between the two gives the mass of the milk. Okay, and then using this relationship between density is equals to mass upon volume, we can calculate the density of milk. So different substances have different densities. As you can see here in this figure, these are the different substances and they all have different densities. Okay, I hope you all have understood what is area and density. So in homework you have to read this lesson up till here, so it will be more clear to you, and further explanation I will give you in the next video. Thank you.